Now entering the Bitcoin Podcast Network.
This episode is brought to you by Shapeshift.io, the easiest, fastest, and most secure way to swap your digital assets. Don't run the risk of leaving your funds on a centralized exchange. Visit Shapeshift.io to get started today. And this episode is also sponsored by my patrons on Patreon. We got about 40 at about $700 a month, and so I like to give different examples each episode for why they support. And here's what Keegan says. He says, I think you're a great dude investing in an important cause, and I want you to be successful. Thank you, Keegan. And today I interview Ryan from Foam, and my highest level takeaway is that Foam is impressive. They've been working on it for a while, and every time that I'd ask questions, it would feel like, oh, I kind of understand that, but wait, there's more unboxing to be had underneath it. So for example, when we talked about proof of location, it was like, oh, we're talking about that, but there's actually static versus dynamic proof of location. And it feels honestly like sometimes when I talk to my friends about crypto, or I say, hey, they say, what do you do? And I say, oh, I do like cryptocurrency stuff. And there's just this endless rabbit hole of questions. That's kind of how it felt with Ryan, in a good way though. So we talk about various things with Ryan today, and primarily we just kind of go over their protocol, the three main things that they have, which is this crypto spatial coordinate system, which is kind of like a latitude and longitude standard for the blockchain. We talk about the UX that they're putting on top of it, and then we talk about kind of proving your location through the blockchain, and especially the static version of proof of location where that uses token curated registries, or TCRs. So we essentially go over all those things and kind of dive into the protocol. And for me, kind of three big interesting things are on my mind after I re-listen to it. The first is, it feels like there's this new crypto economic primitive that's being made where, so if you think about it like this, so Bitcoin is, and I'm not really sure how to explain this, but Bitcoin mining is just, you get the mining rewards just purely with respect to time. So it's a one-dimensional kind of reward function where you say, what is the time? Okay, it was this time, therefore you get this amount of Bitcoins. But now we're seeing these, so someone like Foam does these rewards over both time, but also XY space. And the way that they do that is pretty much if you want, let's say you want location services in a place, well then you signal to show that you want them in a given location, let's say Times Square, and then if someone creates a location anchor there, then they receive more of these block rewards in a location that has more signaling. So this is to say, if you put one of these anchor nodes in a place that has lots of signaling, like Times Square, you'll get more block rewards than if you put it in another place like randomly middle of nowhere in Wyoming. And so that essentially changes the block rewards from a pure one-dimensional time function like Bitcoin to a kind of three-dimensional XY and time function in Foam. And it reminds me of my interview recently with Trent McConaughey in Ocean Protocol, where they use these curation markets for staking for data, where essentially the rewards are given based off of how folks are kind of staking to that data. And again, it's another thing where you're staking to the data and you're essentially saying, hey, when people get rewards from it, those rewards are based off of the stake. So I don't know. I think that there's some kind of crypto economic primitive at this intersection of curation market style staking and these new versions of multi-dimensional space, not just 1D like Bitcoin, but rather in-dimensional, whether it's XY space like Foam or kind of in the data space with Ocean. So that's one kind of interesting takeaway. The second is, so in this podcast, I essentially learn about Tendermint and Plasma, which are these scaling solutions that I know nothing about or very little about, and how Foam is kind of creating something very similar to them. And the idea is that Foam, you essentially, if you want to open up, there's essentially these levels of synchronicity in their system where you say, if I open up this zone anchor, which are these like little places in XY space, and I essentially get a signal. When I signal to that zone anchor, I send a radio signal to it. That zone anchor then puts that in a log in kind of the semi-synchronous fashion, and eventually that semi-synchronous log is put asynchronously back to the main blockchain like Ethereum. And so the interesting thing with this is that, and that anchor node, by the way, the one that was sending the things back to Ethereum, they when they got started up, they had to stake to the main blockchain to say, hey, I will be a good node and I will participate in this network accordingly. And that's pretty similar to some of these like plasma and Tendermint style things, where you are essentially creating a semi-synchronous system that stakes to, or a semi-synchronous like node that essentially stakes to the main chain. So I'm excited to see how stuff like Foam and Plasma and Tendermint kind of overlap and create standards around synchronous, semi-synchronous, and asynchronous kind of staking to the main chain as ways to scale. So that was kind of another thing that we talked about that I was interested by. And the third is this idea of an objective TCR. So Foam really kind of pushes back and says, hey, when we're going to make this token curated registry, this TCR, we want to make sure that ours is objective. And this is and this is kind of in response to this guy Alex from CoinFund, who's pushed back against TCRs, and he says, hey, a TCR, which is a decentralized way to make a list, is really just an oracle. It just gives you say, hey, is this thing on the list? And you say like yes or no, and that's similar to an oracle that says, hey, what was the answer to this question, or whatever, what's the magnitude of this thing. And so when you think about it, so essentially you can imagine a TCR as a one-dimensional version of an oracle, which is kind of just a zero-dimensional, or like just a point in space. And so, but when Alex from CoinFund, he says, hey, if you want to make a TCR, first, an objective answer needs to exist. B, it needs to be publicly observable, and C, it must be really cheap to observe it. And so we're going to kind of see, I bet, a bunch of these new TCRs that instead of just being purely like any kind of random list, instead we're going to see more TCRs like Foam's that have actual objective data that is easy to check. And Foam does it because they essentially do it with point of interest data, where you say, hey, Statue of Liberty is here, and that's like a very easy thing to check against, and a pretty objective thing. So this all say, it was a fascinating episode, and we go kind of relatively deep on a bunch of various crypto economic subjects, and I hope you enjoy. Thanks, and bye. Hello everyone, my name is Reese Lindmark, and you're listening to another episode of Creating a Humanist Blockchain Future. And in this podcast, we take a systems thinking approach to doing good in the world, and we have a couple different series that focus on different system scopes. And today we're focusing on Series C, software systems, where we ask the question, what structures are we making in code? And for today's episode, I'm very happy to introduce Ryan John King to the show. Ryan is a co-founder and CEO of Foam, a protocol for proof of location. Ryan, thanks for being on the show and welcome.
Yeah, Reese, thanks for having me. Really excited to talk more about Foam and the protocols and standards we're building.
Yeah, I'm excited. And as a note, we're doing this live, so we can see each other face to face in the flesh. And so let's start at the high level and say, what is Foam?
Yeah, so Foam is a project primarily right now on the Ethereum ecosystem, where we're trying to bring location standards and spatial protocols to blockchain technology. So currently there is no way to think or reason about location in a way that's standardized. Further, there is no real robust user experience tools, as we know, across the field in applications, but specifically when it comes to adding in map or geospatial data to a DApp, there's no real way to help visualize that. And third, then, there's no way, if blockchain is going to be bleeding into the real world, to verify events in the real world autonomously or trustlessly. So Foam has three different elements to its project: the cryptospatial coordinate for encoding location standards in the smart contract, spatial index visualizer, that's a full-stack general-purpose web app, kind of like a Bloomberg terminal mixed with a Google Maps, so it's a visual blockchain explorer. And the third component is proof of location, a protocol from saying, hey, are these smart contracts with location showing up on the map actually there?
Okay. So yeah, there's three components. There's the cryptospatial coordinates, which is we'll dive into each of them in a second, but that's the standard for saying, here's how you say where your location is on the blockchain.
Yeah, how a smart contract can inherit this location standard, and then they can customize where they claim to be.
Yep, got it. So kind of like something like how if you want to say, hey, I want to be a token, you be an ERC20. If you say, hey, I want to be a location, you use this cryptospatial coordinate standard.
Pretty much exactly. Yeah, it's something free to inherit, and if everyone uses the same standard, then you can start to index the contract spatially and then visualize them in the other elements.
Got it. Yeah, and that's part two, which is once you have everybody using the standard, the CSC, or the cryptospatial coordinates, then you can say, okay, now all of these things have the standard, you can start to visualize them. Instead of looking at blocks with respect to time, you can look at blocks with respect to XY space.
Yeah,
kind of.
exactly. And it's completely, these components are free and open source and for anyone to inherit or build on. So you can, say, let's see every smart contract with a spatial address, or you can then start to build in filters. So if you're only building a supply chain application, or you're only building a Pokemon Go or an NFT game, those can still inherit these properties, and you can still use the visualizer, but you can also siphon off all the other noise and just use these tools for your application.
Yeah, got it. Okay, and then the third piece is, once everybody's using these standards, and people are starting to use them and explore with them in these various ways, then you can actually start to prove your location at a given point in space-time, kind of, and say, hey, or especially space. I guess time is already done by the blockchain, and then once you've proven your location, that can be useful for various apps going forward, for various apps.
Yeah, so we see proof of location as really like a whole horizontal infrastructure that will be, a critical piece of infrastructure that many different applications or verticals can hook into. And it gets a little bit more granular in that we have two portions of proof of location. The first one is called static proof of location. So how do we come to consensus on things that don't move? Okay. And this is what I mean by that is like a geographic point of interest. Let's say City Hall or this piece of real estate. And if any of those were being represented on the blockchain, they can claim a location, and we can come to social consensus on, are these things actually there? And that's where we're using token created registries for really kind of to come to a social consensus, kind of weaker proof of location on, okay, someone made a smart contract with a location. Can we all try to come to consensus on this static point? Dynamic proof of location is now through space and time. We have an entity moving around the city in different places, and it wants to claim its location at different points throughout the day. And that's where really Foam is about a time synchronization protocol. And this is really the almost fourth component, because we're launching with the first three elements, and this future dynamic proof of location is really kind of the most ambitious part of the project and the way to really come to consensus on moving points in a fraud-proof way. Okay,
cool. Yes, there's the static and dynamic, and the static will be used with the TCR, and that's like for all periods of time. City Hall is here, and eventually it might change every 50 or 200 or 500 years or whatever, but generally it's staying there. Versus dynamic, which is like your Uber car driving around or whatever.
Yeah, exactly.
Okay, cool. So we'll come back to that in a sec, but let's go back to the very top one there with the cryptospatial coordinates. And I know I was reading some of the stuff on the website around, there's these really cool things on the internet where you're like, hey, so latitude and longitude are ways to know where you are in time, where you are in space. And there's also these cool, the 3-word thing that says
what 3 words?
What is it called?
What 3 words?
What 3 words? And you say apple, banana, microphone, and then that's this little small square on Earth. Tell me about this new standard that you're building and why it's needed as compared to these other latitude, longitude.
So latitude, longitude is great, and we're not getting rid of it. The idea is that, and it's the most known, but if you want to go down to something like a 3 by 3 meter grid, the actual number of that latitude and longitude string will be extremely long. And so it's not human readable, it's not memorable. And even when it comes to implementing it into the EVM has no float point, and there's no way to standardize, have everyone's contract is actually at a different length of latitude, longitude, etc. And so, just in general, people think location is a solved problem because we have postal addresses and GPS works so great telling us how to get places, but billions of people don't have postal addresses. So location is a problem for them. And there's billions of more parcels of land in the middle of a desert or somewhere that also have no precise location. So this is an unsolved problem. And one way to solve it is something called a geohash. It's an open source standard someone proposed in 2009, and it's not the same cryptographic hash function, but it's like a space-filling geometric curve, and that's a way to really crunch down a latitude and longitude. And that's great, and it's something the cryptospatial coordinate uses. The problem is that geohash is an open standard and free, and as we know, prior to blockchain and new funding mechanisms, open free standards really didn't go anywhere. So this has just been in the public domain for almost 10 years. Well, What 3 Words tries to solve the problem as well, where they assign 3 funky words to any 3 by 3, although it's a proprietary centralized solution. So they're licensing this to Mercedes-Benz train corporations, and they want to solve this world problem. But if they do, they also have world dominance as a central licensed service. So when it comes to encoding location on the blockchain, Latitude and longitude has technical issues, plus it's not very well to represent. And on what 3 words is a centralized licensing service.
Yep.
So what we did is taking this open source solution, the GeoHash,
Yep.
and simply connect that to a smart contract. So we allow any Ethereum address to make an immutable claim to any GeoHash they want.
Okay.
And out of that, a deterministic CSC identifier comes out of that.
Okay.
So the CSC ultimately is derived from a blockchain address making a claim to a GeoHash, and that GeoHash ultimately comes from a latitude and longitude.
Okay.
But it's a problem of location encoding. So it's like, actually, how do we encode this information in a standard way? So the CSC is then a unique 8-digit identifier tag that's then an immutable way, and it's verifiable on and off chain because as part of the proof of location game, I could go to that location and see if the smart contract's there, or I can also look at the blockchain and see what the location encoded in it as well.
Got it. Okay, so when you have something, I guess at a high level, how the GeoHash thing, does it, like, how big are the squares, you know?
Yeah, so it's arbitrarily small, but we've, in our system, set it at a limit of 1 square meter.
Okay, got it.
But it's hierarchical as well. So, like, let's say Brooklyn, we're sitting here in the Navy Yard in Brooklyn.
Yep.
The CSC of the new lab would be derivable that it's in Brooklyn.
Cool.
And the printer in the corner here may have a unique address as well.
Yep.
So it doesn't have to be 1 square meter. It can be larger. But,
Yep.
But a GeoHash can go down to any arbitrary.
Okay, cool.
Precision.
So, and then this GeoHash thing, and then you're essentially taking it, and you're essentially creating that new 8 character representation of the GeoHash, and putting it on the blockchain and saying, hey, and this is what everybody else will use this is what you hope everybody will use as a standard.
Yeah, so if you knew the CSC, you could go to our visualizer and type it in, and it would show you that smart contract. So it's a tool then also for the Block Explorer.
Got it. Okay, so I think that makes sense.
And it's an open free standard. We are working with organizations like the OGC, Open Geospatial Consortium. They set standards worldwide. We're starting a distributed ledger technology working group. And this is something definitely could be improved on. We're open to suggestions, but the idea is just to have an open shared standard to encode location.
Yep. In the end, you don't really care what standard it is. You just want a standard. You think your standard is pretty good, and maybe it has issues. And if there are issues, let them know. You know. Okay.
Because, just not to, we can move on, but we'd look at projects like supply chain and a drone project in the blockchain Ethereum space, and one has latitude, longitude, the other has a street address, and now you have interoperable contracts that can't speak to each other about the space. So that's when we really noticed there was room to introduce a standard. And it's about bringing location to blockchain, not blockchain to location.
Oh.
Well, ultimately, one would surpass the other, but
okay.
I mean, right now, just in blockchain, there is no location standard. So first we'll bring them there, but eventually blockchain, as it eats the world, becomes the standard.
Yes. Okay, cool. So, that makes sense. That's what you mean by we're bringing location to blockchain, and then now the blockchain will have the location standard, and then eventually blockchain will be pushed onto location, i.e. all of the locations will be blockchainified to some extent.
Yeah, or the verticals that take up locations like Uber or a supply chain or an IoT device.
Yeah, okay, cool. So that's the crypto spatial coordinate standard. And then from that, there's this this block explorer, but really it's a geospatial explorer or whatever. So tell me more about that. How does it use the crypto spatial standard?
Yeah, so the spatial index visualizer, it's a full stack web app for Ethereum. It's a React app. And really all the way on the front end, it's based on it's a WebGL, Mapbox.gl, as well as this tool called DeckGL, which is made by Uber's visualization team, which is a really awesome big data visualizer. And we've also, because it's a functional programming app, we've built a PureScript Web3 library. PureScript is this functional front-end programming language that compiles to JavaScript. So we have a PureScript Web3 library, a PureScript Mapbox library, and a PureScript DeckGL library. We built all that. And so from this map in browser, you can deploy smart contracts spatially through MetaMask or Uport. So that in the simple example, I want to deploy a CryptoKitty and give it a home. I can click on the map. It'll tell me its latitude, longitude. It'll deploy it, assign it its CSC. It'll do whatever CryptoKitty call we had. But our backend API, we have a RESTful API written in Haskell and Kubernetes clusters and whatever. So this is listening to the blockchain, indexing events, And once your event was confirmed, this API would feed back the front end, and your CryptoKitty would appear on the map. And now you can apply this to any application. And the idea is that in browser, as a user, you would see events happening in the browser in almost real time from other blockchain users. So the front end can just like basically be fed from the API, everything happening. And it goes in this kind of loop where I can deploy it to the map, and once it's confirmed in the back end, it just shows up on the map. And that's completely, no token or economics involved. It's a general purpose. So we have a developer portal and API, so people could use this in their own applications. And I meant to say that the indexer and the API is listening for contracts with CSEs.
Got it. Yeah.
And you could customize it to say only look for CSEs with this additional tag for a specific app, but this API and indexer is just listening to the blockchain for any contract that inherits a CSE, and then feeds it to the front end and renders it where it should be.
Got it. Cool. So I have a little CryptoKitty, and I say, hey, I want this CryptoKitty to live in my home. My home is a random latitude and longitude, which turns into a geohash, which turns into a CSC. And then I say, hey, I'm going to put it on the blockchain, connect it to the CSC. And then when I do that, then I put it there, and then this web app that you're talking about, the spatial index explorer, is listening on all the different transactions. Like, ooh, do any of these inherit CSC? It says, this one inherited CSC. Great. I'm going to show this on the Explorer, and now my CryptoKitty lives in my home, and it updates on anybody who's looking.
Anyone who's looking at the viewer will then see a new point has been added, and they can then click and explore what it is. And it's also automated from the user side, so you just click where you want it to be on the map, and it assigns it all those geotagged features.
Okay, cool. Okay, so I got that. So now we have the ability to place things in space, and then they show up in this with a UX on top of it, essentially. So then the final piece here is, I guess, getting to the nitty-gritty for why when I think about foam, I thought the word that comes to the top of my mind always is proof of location. I was like, okay, tell me why, I guess, what is the need for proof of location, and how does it relate to these first two concepts that we've talked about?
So it's definitely one of the later things that we developed, and it was born out of all the ideas we had about spatial blockchains and things in the real world. And it really just came down to most of the exciting ideas and applications we had, that if there was no way to prevent fraud and really come to consensus in a shared and distributed way on if entities are where they say they were, none of these ideas are going to work. And you can see as the main example of Pokemon Go, which was relying on GPS, that there was no money at stake, but people went out of their way to lie about their location and unlock Pokemon. So you can imagine...
How did they do that, by the way?
This just highlights why the problem is so serious, in that GPS is extremely accurate for finding out where you are. It's extremely trivial to lie about where you are to someone else. So there's a plethora of spoofer apps in the App Store for even a developer. They need to test different locations for different things. So for me to drop a pin that I'm in China is very trivial for me. And so for me to run this script on my phone that has me walking around the city all day collecting Pokemon while I stay at my desk, well, many of my friends did that. Further, the Pokemon are generated based off OpenStreetMap data. And so the users hacked the map and would add like volcanoes or rivers or lakes to New York City to generate Pokemon or Blastoise. And all the applications like Mapbox or Craigslist that use OpenStreetMaps, they actually got those things rendered.
Funny. It's
and so this has no tokens, no value, and the Pokemon players were like hacking the map as well as lying about their location on GPS. So if you can imagine a scenario where there's an autonomous smart contract with a location parameter, and whether it's a video game or a high-stakes, supply chain handoff, if it will execute autonomously based on a location input, and if you can't verify the origin of that location input, then it might as well not be valid.
Cool. That makes sense. So, and that's what I thought. I was like, how can you really hack something like GPS? But as you say, GPS, it's a really good for one way, where you say, I want to know where I am. It says, here you are. But that's pretty different than just telling some other thing that wants your location, hey, this is where I am, and you just give it some random numbers.
GPS is completely passive, so it's not interactive, so you can't generate any sort of certificate or proof that that's a real GPS message. So when you share it with someone else, they don't know if you made that message up or you actually got it from a satellite at that time.
Interesting. I feel like there's kind of two parts to this proof of location. They're both the same, but it's like one of them is like where I am as an agent operating within the system, and then there's also like where the things are, like the volcanoes.
Yeah.
And then so it's like you need to prove both, because you could either, like if you're trying to hack Pokemon Go, you could either hack it by saying the thing that I want to be near me is near me, or you can say I am near the thing that I want to be.
Yeah, they are one and the same of inverse announcers.
Yeah.
I think the way to refer to it is like secure localization and secure location verification. So localization is like, I'm a device, can I reliably figure out where I am vis-a-vis the network? And usually that's what they rely on GPS for. We want to have a system where they can rely on exclusively the rest of the network and not external things like GPS. So that's localization is like. And a user wants the dynamic proof of location and this radio aspect we haven't gotten into yet. They can localize themselves. There's no blockchain, there's no payment. You just pick up the signals and figure out where you are. So that's localization, and we want to make that a secure process. Location verification is then, okay, I know where I am. Can I prove it to other people in a way that they can trust it?
Interesting. So let's talk about the actual how this actually gets done. And I know it's with these zone anchors and these things. So kind of dive into. I am trying to prove that I am here in the Navy Yard in Brooklyn. How would I prove that through foam?
Yeah. So first, the foam protocol would need to exist here, and that's a different topic we can talk about after. Is how to incentivize people to actually set up coverage. But there needs to be coverage and
cool.
Location coverage would happen over radio waves, so specifically low power, wide area, like IoT radios. But on a high level, the system works the same as GPS in that you have at least 4 stations emitting highly accurate time signatures that are synchronized. And if you can pick up at least 4 of those signals, you can run location algorithms like trilateration and figure out where you are relative to them. So with GPS, you need at least 4 overhead, 1 for X, Y, Z, and a 4th for a time variant. And that's how you can determine where you are.
Cool.
So our thing is essentially the same, that you want to have what we call a zone with at least 4 anchors. And if this zone is running themselves a time synchronization protocol, so they are reliably in sync. So if you as a receiver can pick up at least 4 of their signals, you can then localize yourself vis-a-vis the zone. You could also maybe double back check it with GPS, so that's a way to know if the zone is even accurate or not. And so that's just step 1 of, okay, you have a zone, it's running this time sync protocol. In our case, it's a Byzantine fault tolerant time sync protocol. And the zone is like just in sync. If it's in sync, you can determine your location, localize yourself, right? But the question is then, how do we prove it to other people? So in this, how it differs from GPS is the zone is interactive. So customers can actually send messages back to it, where with GPS you can't. And so here, once the customer picks up the signals, they send like a response message with an associated fee, could be in any token, saying, please include me in your log. And of course they would, because there's money involved, but maybe it's a bribe or a lie. But either way, the zone keeps a log of everything they have, and in a consensus algorithm, which is we can talk about after, almost like its own blockchain. But let's just say they keep this state machine, shared state machine, and they're always in sync, and people send in messages about their location, like keep me in their log. For that log to ever be considered valid, a different entity, verifier, checks all this data for fraud proof and eventually posts it on some parent, root blockchain like Ethereum. And once you're going from instantly figuring out where you are to sending it to the zone, to then the zone's data is being checked, and there's these steps of latency. But once it's on this, once your certificate or your message about where you are gets on that final chain and is checked for fraud proof, it's considered final, and then it's a first-class blockchain object that other contracts or apps could reference, or you could present to other contracts.
Got it. So there are you essentially need to have these 4 different anchors as part of a zone.
At minimum.
At minimum. And so I then connect to them through this Byzantine fault tolerant time sync protocol. Or Byzantine, essentially, they're syncing on time.
They're syncing, and you can trust they're in sync.
Exactly.
Or you have means of checking if they are.
You disincentivize them not to be in sync or whatever. So as I'm there, and I'm part of these 4 different, they say, here I am, then I eventually show to them that, hey, I'm here, and that proves, and they want to essentially, because money's involved, they want to put me on their log, and then that log eventually gets put back to the main chain. So And I guess that part of this is making sure that foam exists here. That's this kind of initial incentivization layer where you incentivize people to put a bunch of different anchors everywhere. And as far as I understand, they're incentivized through, because eventually they're going to, if there are lots of people wanting to use that zone, then those people who want to use that zone will pay them tokens.
Yeah, the revenue model.
Okay, sweet. Yeah, so they say, ooh, this is a place that doesn't have very many anchors. A lot of people are going to need some more anchors here. I'm going to be an anchor. And then once I'm an anchor, then there's a bunch of Uber drivers here for some reason or whatever, and they are all going to pay me.
Definitely, yeah, but you skipped a step in that there's going to be zone anchors and there's going to be no customers. Right? So the question is, how do we actually bootstrap this system and have coverage prior to the customers being there, right? So if you imagine if we set up zones tomorrow, there's not a fleet of smart contract Uber cars ready to pay. Yes. And so that's why we have a block reward and mining rewards in Foam as an incentive bootstrapping mechanism of, can we set up these zones and run them? And because we're just simply following the protocol and broadcasting correctly, we are now eligible for new tokens. And so the only way to mine tokens is by setting up zones. And further, there's a component called signaling, where people can stake tokens in a CSC on the spatial index. And the signal shows a demand for location services, and the block reward is spatially weighted, so it's distributed where there's a higher signal. So pre-launch, people will signal where they're going to set it up, and they'll be boosting their own rewards, so they're won't be wanting to test it and help set it up. Once this time sync proof of location is running, people can signal where there are no zones, and even if there's no customers there, if I set up a zone there, I'm going to get a higher block reward than if I stayed where everyone else is in New York.
Interesting.
And so the signaling serves as a way to drive the coverage and drive the supply, so that the token distribution is not just over time with a half-life, but it's actually distributed to different locations based on the signal and the demand.
Got it. Okay, sweet.
So that's kind of how we address the how would there ever be a zone here in the first place? And if there's no one who's going to be paying them as a customer, maybe for a few years or more until this really matures, there is like a bootstrapping incentive mechanism.
Cool. Okay. So we are trying to get these zone anchors set up essentially around here, and in order to do so, what you do is you say, hey, if you place an anchor in the system, then that's how you get some of the initial block rewards. And you can get more block rewards at the beginning if certain people, as you say, it's not just, if you think about the blockchain in XY space, then you say, hey, I'm staking, I really want a bunch of, let's say I live somewhere where I want people to set up anchors, then I personally would stake to that location, and then people would then come and say, oh, I will get higher block rewards as a result of people staking to this spot. Is that correct?
And people might signal, even going back a bit, during the static proof of location, while we're just curating static points of interest. I might signal because I want to say, I need secure location services here because I want to make sure everyone voting actually went to the building and checked it out. So people who are curating points of interest may also want to signal because for them it's a security upgrade, because now you can reduce Sybil attacks and actually guarantee the curators, or even where they, in our case we call them cartographers, are actually in the area that they claim to be curating.
Got it. Okay, interesting.
So it's just like a general way to coordinate people to build out the system themselves. Like Foam proof of location will have to be community driven, decentralized, and people contributing work in their own manner. So we need an incentive mechanism to help people build it out. If we just built it ourselves, we'd be recreating a centralized system.
Oh god, and I think that it's interesting the incentives that you're placing. It's not just purely they're incentives. The people are incentivized to place these anchors from a block reward, essentially what I think of as like a staked curation market block reward perspective, and from a later on, once the customers are there, then they get rewards from being used to get revenue.
Exactly.
Okay.
So someone may be able to say, oh, okay, Times Square, it's in our case, mining difficulty is number of peers nearby, and let's say, okay, Times Square, I'm not really getting a high block reward, but the revenue is great. Who cares? But another guy might say, oh, across the river in New Jersey, there's no customers there, but people are signaling, and if I just simply relocated, it would actually be more profitable for me. And that's the kind of ultimate algorithm or function that we want, where there's always a means for people to want to actually expand the system. So even if I was some sort of Sybil actor or could buy up 10% of the foam supply, the most profitable thing I could do is not run all my zones in New York, but put them in different places. And then I'm just helping spread the networks.
Got it. And when you say for someone to be in that location, so let's say I was in Times Square, because I was one of the first people in Times Square, and I got some of, there was a lot of staking stuff there. I got some of the initial those block rewards, and then some customers went there, and I got a lot of the money that was being pushed through, but then a bunch of other people came, and so the difficulty was too high. So I'm like, I'm going to New Jersey. How would do I need to actually move to New Jersey? Or like,
if you wanted to run a zone anchor there.
Okay, and tell me why that's true. Yeah.
Why?
How would I need to? Why does your system require me to be in the location where I set up a zone anchor?
Well, you don't as a human, but your zone anchor can't move.
Okay.
So you can also say, hey, I have made some revenue. I'm going to keep this guy running in New York, and personally, I'll go set one up, another additional one somewhere else.
Yep. And then let's say I go to New Jersey and set up the zone anchor, I'm there. I set up the new zone anchor, and the zone anchor, it's required to be in that. How does the world know that zone anchor is there, I guess?
Yeah, good question. Well, one, if I wanted to go set up a new zone, I don't need to set up all 4 anchors myself, but there had to at least be 3 waiting for me.
Okay.
So there's one component. 2, there's a confusion that many people have when we get into talking about this, where they want to know how the system knows about absolute location. And the first answer is it doesn't. Like, the time sync protocol helps nodes determine their own geometry. It's abstract, whether it's on Mars or on the Earth. It just can tell you the distance between the nodes, so it's relative in that case. So if I set up a zone in New Jersey, and I claim that I claim I'm in New Jersey, and I actually set up a zone in Alaska. Let's say I'm running the protocol properly, so it looks like I'm well formed, so I'm getting block rewards. Well, one, I don't get any customers because no one can find me, and they can't communicate with me because they have to be in proximity. And 2, as soon as the rest of the zone anchors try to join my zone and no one can get in touch with me, now I'm going to be slashed, and I'm going to lose my stake. So there's a very little reward from setting up a zone in a fake location, and then further, out of people using these zones or them being durable or over time, we probably see as a second layer consensus TCR on absolute positions or something like that.
Got it. So if I think this gets to this idea of the time sync protocol. And so could you guys just explain that a little bit more deeply for me?
Definitely.
Yeah. How, and I guess from the point of view is, if I pretend to be in Alaska and I'm not there, how would the others know that I'm not there and then slash my stake?
Yeah. It's simultaneously very simple and complicated. So in the sense that, the questions about time synchronization and location are very intertwined. So questions about time and space, as we know. So how location in real-time systems is determined today, as in a standard sense, is over radio waves with synchronized clocks. So that's fundamentally, GPS relies on atomic clocks that with base stations coordinating them all together. Yeah. But there are plenty of other just wireless network systems that rely on clock synchronization. And through time of flight, or the difference of time of flight of different nodes, if they have synchronized clocks, you can then determine distance. And if you have enough nodes, you can point actually to where it is. Maybe with only 3, it's 100 miles to the left or to the right, but with at least 5, you could pinpoint where it is. So that's how time sync helps aiding location.
Got it.
So we're doing the exact same thing, where we have a time sync protocol, and because all the clocks are in sync from the timestamps of the radio messages, a receiver could determine their own location. We want it to be Byzantine fault tolerant because there's no central place where they're synchronizing, and which most systems have. And by fault tolerant, I mean it can survive and self-stabilize if up to 1/3 of the nodes are faulty or break. And through this fault tolerant time synchronization protocol, any zone of nodes can determine its own geometry of the network without an external input like GPS. So just by simply running this protocol, the nodes in the protocol can determine where each other are relative to each other. And that's all it can do. It can't tell you if it's in London or if it's in New York. But that's what the time sync is providing.
Got it.
And through then, this is then a synchronous protocol. And all this kind of synchronous data is then stored in a state machine shared by the zone. And this shared state machine is then a different kind of consensus of basically partial synchronicity. And this is where we imagine something like Tendermint consensus comes in, where over radio you have this time sync protocol, but the zone then has to actually store that and log that data and vote on the shared state. And for that they can use like Tendermint, which has instant finality. It never forks, so you don't have a zone's data forking. And then they have this log building up over time.
Cool.
And that's also Byzantine fault tolerance. So you have this like reliable radio protocol, and through those signals location can be determined. And then you have this log protocol that's also stable and fault tolerant. So now as location customers get the data they need to learn their location, they send it into the zone and they ask, hey, can you put this in your basically Tendermint blockchain?
Got it. Okay, so we're gonna, and just to check, do you have, if possible, can we go to 23 more minutes, by the way?
Yeah.
This episode is brought to you by Shapeshift.io, the world's leading trustless digital asset exchange. Quickly swap between dozens of cryptocurrencies, including Bitcoin, Ether, Dash, Bitcoin Cash, Augur, Golem, and many more. And this is not your typical crypto exchange. You don't need to create an account or share your personal information, and your funds are never stored on Shapeshift. This means that your hard-earned digital wealth is never up for grabs by hackers or other malicious actors. To get started, visit Shapeshift.io, choose the tokens you'd like to swap, input your receiving address, and send your funds. It's that easy. Okay, sweet.
I have a meeting at 5.
Okay, nice, great. So let's, because I think that this is essentially usually people sync up on atomic clocks, but you guys won't be using atomic clocks, but you'll be using your time sync protocol in order to make sure people are synced up.
The zones could be using chip-size atomic clocks. The customers, like now, like the GPS are synced in atomic clocks, but you as a receiver just
Got
the
it.
messages.
Got it. So the anchors. So if I make an anchor, do I need to be using an atomic clock?
Ultimately, because the protocol is radio agnostic, we imagine different zones would have different tiers of precision.
Interesting. Okay, interesting.
And different tiers of like money spent on
that,
because the protocol works up to 1 clock tick.
Okay.
So then the question is, well, how accurate is that tick?
Interesting.
And millisecond versus nanosecond is like a massive difference. And if you have the more precise the clocks, the more accurate the whole protocol can be.
Okay, got it. So each zone has to be homogeneous with respect to the kind of sync that it's using. Some might be using atomic, some might be using less than atomic.
And like the full vision of what this could be in that, this is so important that actually we need specific middle of the ocean, low satellite zones. But at the end of the day, everyone's still running the same message types, the same protocol. It can be verifiers, and then could be assigned all different zones. The data type, they're still checking it the same. It's just that one zone might have higher accurate data, one might have lower, and even if they all have the same clocks, because one's in South America and one's in North America, just like weather and time and how it affects crystals and like speed of atoms. Like when you get down to it, there's no two zones will be the same.
Yes,
even if they have the same hardware.
Yes, that makes sense. Okay, cool. So I think I get that, which is, so at a high level, you're making to just recap where we are now. There's the standards, the crypto, the CSC, the crypto spatial coordinates, sorry. And then those allow you to, that's a standard for kind of like a latitude and longitude before the blockchain. And then within that, you have this explorer that can explore based off of, that essentially is a UX on top of that CSC standard. And then from that, we also have this proof of location thing where it's like, we need to prove location or else people will hack it in the way that they've hacked stuff like Pokemon Go in the past, and especially as we get things where Pokemon Go, there was no real money at stake, just like various weird things of reputation. As more value gets placed into that, we'll need to prove our location better, and you guys have a system that uses anchors. Essentially, you're going to bootstrap the system through cool incentivization schemes like staking and what have you to bootstrap a network of all these anchors around the world, and they will have they will know where they are relative to each other because everybody will be synced through this time sync protocol. Moderately, okay, nice. That was I got a moderately good nod from Ryan, so I feel fine with that. Okay, so from that, let's talk. There's two final pieces I want to talk about today. One is the TCR side of things. So let's start with that. So you talked about within proof of location, there's dynamic proof of location, which is going to be later, but static proof of location, and you're saying that we're likely to use static proof of location with these TCRs at the beginning. Is that right?
That's what we'll be launching with, basically. In that it's this idea of, can we take CSCs, cryptospatial coordinates, combine them with token curated registries as a primitive, combine the standard with a primitive, I guess, and come out with a new way to think about points of interest.
Okay.
And points of interest, maybe not everyone would be familiar with what it means, but it just means like literally what are the interesting things on a map.
Yep.
But it actually comes down to modern proof of interest data. This is like up to $1 billion marketplaces, and Google has a large monopoly on those POI data. Foursquare, it's their number one business model, is selling POI data from their API. And there's millions of change sets a week to OpenStreetMap, so there are also just open contributors to POI data. But we see that there are no, in the open way, like OpenStreetMap, there's no real incentive to keep adding more points, and there's definitely no verification. It's very fun to add points. It's not as fun to police the map, especially when there's no winnings to get.
Yes.
So we have this idea of like, can we actually build a consensus-driven map of the world that actually has incentives and is based on a new form of cartography where people actually can curate and vote on the data on the map.
Got it. Okay, so in the way that this would work is with a TCR, aka a token curated registry, you would say for this this CSC for this area, would I claim, are the TCRs with respect to how, is there one TCR for every what,
Yeah, so we're interested in the difference between objective and subjective TCRs. And one of the thinkings behind these lists is that if you don't have enough curators, it's really hard to maintain a quality list.
Yeah.
And so when you think about subjective spatial lists, and I know in TCR discourse, even when previous podcast with Mike Golden, people always use an example of like favorite sushi restaurants or like favorite places, favorite locations. So it is kind of intuitive to think about locations, but those are all very subjective. And so when it comes to objective data, we just want to know are all these places actually where they claim to be? And that's all. So we're launching with this one, kind of master TCR based on objective data.
Okay.
In this case, the list itself is the map. So you're not looking at a list, you're actually looking at a visualization of points, and you can see a green point means it's on the list, a red point means it's currently challenged, a blue point is an application, and that's how and a user can then, favorite points, tag them or interact with them. And it's also based on a ranking system. So Google ranks points based on how popular they are. So at certain zoom levels, you actually see, the most popular businesses or points. So based on how much stake is left in the point can influence that, and people could add points to it or withdraw in the future, and that's this dynamic aspect. But the idea is then to build in tools so people to build their own custom TCRs out of this. And maybe they build more and more objective ones that are just about cities, states, and towns, and then people start to build ones based on favorite parks, favorite restaurants and tools, and potentially those have their own tokens and their own ways to launch them and create them. That's definitely something that we see a lot of potential to explore, but is not the starting point.
Yeah. So, and at the beginning, and this is Alex from Coin Fund had a good critical argument or good critical piece recently against TCRs and how there's only one live one today, which is the ad chain TCR, and B, within TCRs there are you can think of them as a variant on an oracle, and when you have oracles work in theory because objectivity is one of the big three things that they have. It's objectiveness, it's publicly observable, and it's very cheap to observe it. And it feels like this point of interest data might check all three of those boxes.
Yeah, we definitely think so. And there probably won't be that many challengers to begin with because people will care about curating this high quality list. But as we talked about earlier, as soon as a game like Pokemon comes in that references the map data, people will maybe start to add bogus points, and the curators would want to challenge it. And another aspect is people who want to be really objective and help build out this consensus map of the world, something that's a point of truth. And I'm here in Dumbo, Brooklyn, and this new organic deli just opened, and it's not on Google Maps. And I was trying to find out what hours it was open. I didn't even know who to call or what they were called even. I just knew it opened recently. And so there's a latency of things getting added to the map, so people can start to build this single source of truth and create a consensus driven. But even if it is objective and hits these points that match don't match Alex's critique rather, there's still a lot of problems with TCRs. There is only one live one. We don't know how they work. to the fullest extent. Sybil attacks are extremely trivial. So we see this also as an experiment and a way to show why dynamic proof of location would be needed to help support even curating objective information.
Got it. And so within, just to make sure I understand this TCR, is there just one TCR for the whole map?
Yeah, for launch, and then like mitosis or sub list can start to be born out of that. We're starting to experiment with sister projects like Relevant and new ways to make bonding curves of how actually you have these trees of sub lists if they're all connected to the master one, or how to actually introduce new tokens, and that's an area still under exploration.
Yes. Okay, cool. So that makes sense that you have if I go and I look at your variant on the Block Explorer, the XY Block Explorer, and I don't want to see a bunch of random volcanoes in New York City when I'm looking at that, and that they put on there from Pokemon Go. And so we instead have a TCR, which will hopefully be a good way for people to curate what is actually on that list. And as you say, the green things will be on it, and the red things will be off it. And that will allow us the initial time to say for static things whether they are or are not on this list. So that makes sense. Let's do this final piece here, which is this. I heard you talked about it recently in this one. You also chat about it in a podcast with Epicenter recently. How it sounds like for a given anchor set, essentially a given zone, you're conceptualizing of it in kind of this Tendermint way of things, but also in the plasma child chain version of things. So could we kind of unbox that for a second? And for me personally, I haven't done much research into either, and so don't know much about either, but we might be able to understand all three of them, both your system and those two systems, based off of your explanation of them in respect to each other.
Sure, I'll give it a shot. It's definitely a more generalized, so I can start with the fact that we've been speaking about zones and how people might want to be a validator in these zones. So the question is, how do they actually join, which you asked earlier. I explained how they join in the physical way, like they have to set up a hardware and turn it on and run the protocol. Yeah. But to actually be a valid participant, they actually need to stake on a parent chain or a root chain. Okay. And so this would be like Ethereum. Yeah. Conceptually, it could be something like Dfinity or something else. So and that stake is what we call a service level agreement, like an SLA. And so the zone is basically staking on this parent chain saying, hey, we're going to be running this zone for the next 5 months. We promise to have like 98% uptime. We're not going to be faulty. And we subject ourselves to being slashed with this stake. So as I mentioned earlier, the actual time synchronization is a synchronous protocol, like by nature. And the way that they're logging this is what we imagine to be a Tendermint state machine. Okay. And so that's partially synchronous protocol. Okay. And ultimately, the security would be derived then on these stakes that I referred to, which is on an asynchronous protocol, meaning like Ethereum proof of work or eventually proof of stake. And so Foam proof of location as a whole relies on this synchronous, partially synchronous, and asynchronous consensus. And we're not exactly sure if it would be a plasma construction or a Cosmos IBC construction interchain, but the idea is you have stake occurring on some master chain as a way to enter, to become a validator in this subchain, and that subchain is the zone. Yep. And then you're keeping that consensus log and then also broadcasting over radio. Okay. And so this kind of like 3 stages where if I want to be a zone, I first stake on the master chain. It allows me then to send out the correct messages I need, and then once my zone's up and running, this verifier checks the zone's data and for fraud proof and goes back to the parent chain as well and says, hey, don't slash them, actually give them mining rewards. Yeah. Okay, got it. So essentially you have the zones, and the zones are, essentially make a stake to the root chain, any kind of smart contract platform, let's say Ethereum, and you say, hey, I'm going to be an awesome person, I'm going to make this zone here, and it's going to be up for these various times, and I'm going to have a good consensus, whatever. When I do that, that's happening, and then these verifiers go and they check. They can say, "Oh man, no, you're totally wrong," know, and then they can slash you, or they can say, "Actually, you're right." Therefore, give this person block rewards. And then one step further, the actual users or location customers, they pay to get their data in the zone. So the verifiers can say, "Hey, the zone is well formed, but they have all this junk data in there. Don't put that on the root chain."
Okay, got it. And tell me. And dive a little bit deeper on what you mean by, you talked about a fully synchronous protocol, a kind of synchronous protocol being Tendermint, and then an asynchronous protocol. How would you relate those three things?
Yeah, I'm definitely not the best expert in consensus algorithms. I rely on some of my consultants, but really there's this thing called the CAP theorem, which is like trade-offs between consistency, availability, and partition tolerance. And so the main differentiation, the trade-offs is like that Tendermint and Casper, at least the friendly finality gadget, they make different trade-offs in this CAP theorem against consistency and availability. And so in the partially synchronous one, what that means is the voting aspect happens in a different kind of order, but at least the messages are always sent in order, so that's why it's partially synchronous. And the Tendermint trade-off is in availability, so it'll never fork, but that means it might be off. And it has instant finality, or within like 3 seconds. But so why is that good for a zone? Well, that means the zone blockchain is really fast. It finalizes its data logs really quickly, and if it passes this 1/3, Byzantine fault threshold, the zone just turns off. So you don't have now a zone forking and producing two types of presence claims everywhere. So that's why we were interested in Tendermint for that, and it would work really well as an IoT stack, and not very tested. So obviously we were looking to work closely with the Tendermint team on building this out. What do we mean by then asynchronous protocol, like a Nakamoto consensus, in that Bitcoin is running on the internet, which is not in sync, and there is no shared clocks. Bitcoin itself has a timestamp way to keep track of some sort of consensus on time, but otherwise, blocks are being added or not asynchronously, and it does fork like Ethereum could. So you could be mining on the wrong chain for some time and then realize, whoops, and then sync back in. So that's all asynchronous, and eventually, even if there's forks, it eventually all figured out which is the right chain to be on.
Got it.
And so that's like the difference, I think.
Cool. Yeah. So you have the semi-synchronous protocol,
which is just basically keeping the log of the sync one.
Yeah. Okay. Yep. Oh, yeah. That's funny. Yeah. So the sync one is going
over radio.
Yeah. Exactly.
Each node, from their point of view, well, they're getting messages in the same order every time, because the anchors don't move, so it's just they're synchronously logging the data they get.
They're synchronously logging the data.
It shouldn't change after the first time because they don't move.
Yeah, and then the semi-synchronous one logs them all, and you want that to be fast, so you use a Tendermint style, as you talk about this CAP theorem, where you just say, hey, things are going to go fast, and as you said, if there's an attack or something like that, it just goes down instead of forking, but that's in this trade-off space, and so you allow the speed there, which is great, and then finally you eventually go back to the asynchronous protocol and then validate things on the root chain or whatever.
The Merkle root of and so that's just like a header of like, hey, my presence claim I bought last year, it still exists on block 8,000 on the main Ethereum chain. It's immutable. It doesn't matter that the zone's service level agreement's over and they trash the data. My location's been proven and it's on this asynchronous immutable block.
Yes, great. Cool. Well, that was I got most of that, so I think that was okay. Well, Ryan, the other note here is just, and we're not going to go into much of these, but there's the other things that they're doing which are cool are they have a functional programming stack, and as some of my listeners know, I'm into functional programming. It gives you a new mental model through which to view the world, and I think it's very powerful, so that's interesting. So if you're interested in functional programming plus blockchain crypto stuff, definitely check it out.
And we have a number of libraries as well as a developer portal, developer.foam.space, that has more of the foam-specific tools, but our GitHub has general purpose functional programming Ethereum libraries as well. Yeah,
so that's sweet. The other sweet thing that we didn't talk about was they're working with Token Foundry, which is out of Consensus, and with them, they're working on a bunch, and we talked about it a bit, but like these ways through which we can do these new kinds of token sales where we don't actually just like give all the tokens to whoever, but rather you say, hey, you need to prove that you want to be a part of our network and be, they're doing cool new token sale design by making participants actually participate in order to get part of it. Is that right?
Our sales structure has a proof of use function, and we're not looking to distribute to speculators, but really need to have distribution to people to help build this protocol out, and are not doing so to expect necessarily profit, but to help contribute work. So we've partnered with the Brooklyn Project as well, which is an initiative by Consensus, as well as Token Foundry, a new token sale platform on basically consumer compliant tokens that'll be going straight to mainnet and really have this proof of use functionality where if you want to participate and secure an allocation, you have to basically show that you're going to help build out this decentralized network.
Yeah, that's sweet. So those are also cool things. And just as a reminder, we talked about the other stuff from above, mainly the standards, the crypto spatial coordinates, the UX on top of those, and then the proof of location and the variance on within that. TCRs for static, others for dynamic, which we didn't go too much into. And then finally, we talked a little bit about, and Brian helped me more understand how their system is similar to a Tendermint style semi-synchronous consensus protocol. So with that, Brian, thank you again so much for being on the show.
Yeah, thanks so much, Reese. And if anyone wants to reach out to the Foam Space Twitter or our website's foam.space or join our Telegram, we're happy to answer any questions or see you join the community.
Definitely, yeah. And with that, thank you everybody for listening. And if you want to, so definitely honestly check them out. Foam.space is the website address. And if you want to support me, you can go to patreon.com/ReesLindmark. That's patreon.com/RHYSLINDMARK. And you can also go to StakeTree.com/ReesLindmark as well. Okay, thank you everybody and goodbye.